All right, it's time for a new episode of Go Talk. Today I have Anders. I don't know how to say your last. Kierulf?
Kierulf works.
Kierulf.
Yep.
Anders is a good friend of mine, I hope, and we've known each other for a while. And Anders is the developer behind SmartGo, and we're going to talk about a lot of things, be it computers, because there's a lot of news that's coming up about that, and just Anders in general. So, welcome, Anders.
Yeah. Hi, Kevin.
So let's start with the biggest news because everyone is really buzzing about this, and that's AlphaGo. How'd you
Yep.
feel when you first heard that AlphaGo was able to beat a professional?
Oh, it was a huge surprise. Yeah, I woke up and saw something on Twitter and thought, "Oh, that must be a mistake," and then started digging and found out that yeah, Google really had done it. And basically, it was not something that I had expected to happen for at least 5 years, probably more like 10 years. And so suddenly they had jumped 4 handicap stones um, to beat a professional player.
Yeah,
And yeah,
definitely, it was
amazing.
something that surprised me as well. It is funny how a lot of people talked about it when they usually talked about the whole Go AI was that they usually did put it about 5 to 10 years away. And so, do you think when you heard this and you read the paper, was it just that they found a new way of approaching it, or what were your thoughts?
They they did some things a bit differently. So I think we can talk more about kind of how Computer Go used to work and how it has been working recently with Monte Carlo, and then what Google did to kind of change that. But yeah, they did it a little bit differently, and they threw a lot of computing power at it, and added a lot of deep learning into the mix.
Yeah,
So
and it's interesting how I there's been a lot of press and a lot of people tackling it, and it's nice just because there's a lot of people that are actually focused on this. I mean, I know Facebook's had their version, and Google's had their version, and even then, before this, uh, there was that whole. There's always the yearly Go Go AI tournament, right?
right, right, and the computers have been making slow but steady progress and improving. But yeah, they were still some distance away.
So what? How excited are you for this big
Oh,
tournament?
I'm very excited. Yeah, yeah. This is amazing having the match with Lisa Doll. So yeah, I think so. We only have 5 games that we can look at from AlphaGo to see how it plays.
Hmm.
But we know that when we played 5 other games too, which we don't get to see, and he actually won 2 of those 5 games, the unofficial games,
Right.
and we've seen some mistakes that AlphaGo has made. So if you look at the analysis that professionals have given of the games, it's clear that it's making some mistakes.
Hmm.
But that was the October version of AlphaGo. And so Google has 5 months until the match in March to improve things. And yeah, apparently they have been improving things. So I expect kind of that they definitely step it up a level. And whereas in October they were clearly still below Lisa Dole, it's not clear what's going to happen in March. It's really exciting.
Do you have any certain, barring predictions, do you have any hopes of what you would like to see?
Oh,
Uh,
I hope that Lisa Dole wins, because that keeps the interest alive for longer and keeps Go in kind of in the news more, because then there will be another tournament where they challenge Lisa Dole or somebody else, and if they win this first time, then it sort of fades away a bit.
yeah, I
So
agree with that.
I hope he wins. I think he will win. maybe lose 1 or 2 games, but I think he'll win. But who knows? Uh, Google has a lot of things that they can throw at this.
They can probably just throw all of their servers at it, and
Yeah,
the whole internet will stop just for this to run.
yeah,
But yeah, I'm in the same boat. I'm hoping that the humans will win this time. It there's a strange for me. There was a strange sadness because it is the one thing that we as Go players always like to say is like, oh, this is the game that uh, you know computers have yet to be able to beat a professional at. And I've said it, I've
right.
thought it before, but it is funny how we keep moving the goalposts back to so we can deny it. But it does feel like it's an eventuality now. Do
Yeah.
you feel the same way?
Well, it was always going to come at some point, but it's a surprise that it came this early.
So you were actually a pretty strong believer that sometime in the future that computers would be able to beat
Yeah,
humans.
yeah, definitely. Yeah,
Huh.
yeah, that was inevitable. Yeah,
Nuts.
computers get faster. We get better at writing software. We figure things out. So you could see the progress of Computer Go. It's been going towards beating a professional, just not at that speed.
Yeah, definitely. So we're gonna have to definitely see what happens. I think it's in 2 weeks now, and
Yeah.
it's impressive the build up to it. I mean, everyone has their own side. In terms of even I think his name's Demi or Demis. I forget.
Uh, yeah, Demi Hasabi, I think.
Hmm.
Hasabi's-
He's definitely saying that it's improving in ways that he doesn't know, which is an odd way of saying it. And then also, obviously, a lot of the Koreans are promoting their own pro because I mean it's a homegrown, it's their hometown champ.
Right.
Um, Actually, let's talk a little bit about that. I mean, is it when he's saying that it's improving in ways that he doesn't understand? Is that just because under the hood, even the programmer doesn't know how the program is like thinking these things out?
Right. So, yeah, should we transition into kind of how the program works?
Yeah.
Because may have to. So let's go back in time a bit and look at chess programs.
Okay.
So, uh, chess programs had a big success by just using brute force. So you look a number of moves ahead, 10 moves ahead, 15 moves ahead, and then you evaluate the position at that point, and you basically find the sequence that leads to the best result for you, assuming that the opponent will do the best to stop you
Right.
from getting there. And with computers being really fast, you can search a lot of moves, and when you get like 10 moves out, you can really evaluate the position. In chess, you can basically look at the board, and you can look at the material on the board. You can make adjustments for doubled pawns and things like that, and you can get a pretty good idea of how good is this chess position.
Hmm.
And so in Go, that was one of the approaches that people took, was also kind of, okay, well, we'll look some moves ahead, we'll evaluate the position. And that turned out not to work that well.
Yeah.
And so one problem is you just have a lot more moves. But the main problem is that you don't have a good evaluation function. When you look some moves ahead and you try to figure out, okay, how good is this position? You have to look at all the different tactical things going on the board. You have to see, are things alive or dead? Are they connected or not? Is
Local
this
and global.
right? Is this territory? Is this Moyo? Can this be invaded? And it's really hard to try to figure that out. And so you might have to do extra searches and things to try to figure out the local positions, and then you have to tie it all together. And so that never quite worked really well. There were always kind of holes in that analysis, and computer was really good at finding those holes and steering the position towards something that was wrong.
Right.
Um, so about 10 years ago, people started a different approach called the Monte Carlo uh, approach. And there, instead of evaluating the position, what you do is you play a more or less random game from the current position all the way to the end of the game.
Hmm.
And at the end of the game, it's trivial. You see, okay, black wins or white wins.
Right.
Then, starting at your current position again, you play another random game to the end of game, find out who wins then. And after you do this 1,000 times, you see that, okay, I start with A, I win 60% of the time. I start with B, I win 55% of the time.
Oh, I see.
Maybe A is a little bit better than B. And so then you, on top of that approach, you add tree search and statistical analysis,
Hmm.
and sort of so that you look deeper into those variations that can actually kind of change your opinion on the result.
Mm.
And that
So is it sort of like a more elegant brute force? It sounds like that to me.
so it's a brute force in a way that you can it's scalable. You can, like the chess programs, you could throw more computing power at it and it got better.
Right.
And with this Monte Carlo approach, you could also throw more computing power at it and it got better.
I see.
And so that was like 10 years ago. And since then, programs have really kind of started making more progress again at a
So
faster
this
rate.
is it sort of like the Newton apple falling sort of, oh, there's a completely new way of looking at this type.
Yeah, that was a completely new way. And to me, that was a also very surprising way of looking at it. When I first heard about the Monte Carlo approach, I thought, yeah, that's not going to work because you just look at these random moves and there's no way that's going to work. But if you combine it with the tree search and you you can't play a completely random game. You have to be reasonably smart at how you select the moves
Hmm.
in that random game you play so that it's balanced for both sides.
Right.
Um, but when you do that, you can really achieve amazing results.
Okay.
And actually, a little bit after Google announced their result, there was a program, Zen,
Hmm.
that had reached like 6 Dan on KGS.
Wow.
And they were using basically this approach. And that would have been big news if Google hadn't come out of this just before. But
And then I guess so. It was originally brute force, and
mhm.
so then that was until so the general date is around 2006. I guess was when they finally decided this Monte Carlo
Right.
approach,
Yeah, 2005, 2006. Yeah.
and then now we have 2016 where AlphaGo has yet another. It's like another layer on top of that, right?
Right. So what they have done compared to the regular Monte Carlo tree search, um, so for one thing, they have used deep learning with neural networks
Mm-hmm.
to um, try to really kind of fine tune uh, the parameters um, for two things. One for looking ahead, kind
Mm-hmm.
of the policy for which moves to look at in that random play out to the end.
Okay. Yeah.
And what they've also done is that they have taken 30 million board positions and thrown that at a neural network and uh, evaluated, okay, are these good for black or good for white?
Mm.
And used learning basically to just evaluate a position, which goes back to more of the previous approach of kind of just looking at the position and figuring out how good it is.
Mm-hmm.
And then at each point in the game, they combine those two approaches. So they both they look to the very end of the game and run all these Monte Carlo simulations. At the same time, they do this evaluation of the position using this neural network.
Uh,
And it takes, I think, did it take about 15,000 times longer to kind of do the evaluation of the position than to run one of those simulations. So they
mm-hmm.
can run a lot of simulations. So that they have a lot of complexity in kind of getting the results from both of those, combining them back together
Right.
and doing the search. And they do the search in parallel on lots of processors, lots of GPUs also. And doing that, they made a big jump in their performance.
So is it sort of like two people looking at the position in different ways, and then they compare and contrast, and they allow that to maybe choose the
In
better move?
Yeah, in a way that combines in 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 a way that kind of makes each of them stronger. They they
Oh,
they kind of in their paper they show that if they just do one, it gets to one level. If they just do the other, it gets to another level. If they combine both, it improves on both of those.
and I think they said that on the paper because I remember them talking about how if they just did one of the networks, it was about comparable to where computers are now, just as a general rule.
Right,
But it was because of that second AI or whatever that allowed it to play even better.
right, yeah. And so looking at that, there are a number of things that Google can do in those 5 months leading up to the Lee Sedol match. So whereas before they built this neural network based on 30 million positions,
Mm.
they can take 100 million positions and
Oh,
do that. So they get a better quality of the evaluation. They can retune the policy network to kind of get the playouts to be better. And what they also did was they figured out this policy network to get the playouts to be better, and then they used those playouts in the to evaluate those 30 million positions. So they sort of one part that they improved, they used to improve the other part,
oh, interesting,
and they can sort of do that again.
interesting.
So yeah, so it's going to be really interesting what they come up with um, in March.
Yeah, and the interesting thing, so, but at the end of the day, this is the thing, sort of strange about it is like, will it be able to explain why it made a move the way like pros can explain it, or will it still just be like they made a move that they understand, but humans might like will we be able to understand what they did? Or in a way that
They
like they said, I played this because of this, or is it just going to be a statistical like out of all the models this worked well?
I think they can give us the sequence of moves that
Oh,
they sort of predicted will happen, and that will give us an idea of okay, this is what it was kind of thinking about. Because when
oh,
you
cool.
do the Monte Carlo tree search, you kind of get one variation that you explore deeper, and you find out okay, this is sort of what you think. So
Oh,
that
cool.
will give some kind of explanation. Like often when you talk to a pro and you ask, oh, what happens in this position?
Right.
They often just show you a sequence of moves on the board and show you, oh, this is what happens,
Oh,
and
interesting.
so the computer might be able to do that, but it won't. I don't think it will be able to um, say, yeah, I played this because I was weak over here and I wanted to attack over there and something like that. It won't have that kind of grasp of the situation.
Oh, interesting. Yeah, there's a lot about it that's really useful just to learn, and I say interesting a lot, but it's pretty interesting to me. I think the one thing I talked to Eric about how he gets better, and he says he plays a lot of games and he studies a lot of games, and it's just to see how things interact with each other, and then to hear how AlphaGo's been doing and how AlphaGo's been learning. It feels very much like what pros do in order to get better. They play a lot of fast games to simulate what happens. They look at other previous simulations to see what it's better, and it's just there is that really interesting feeling of, oh wow, it's almost mimicking, or they're trying to learn in the same way.
Yeah, but it learns from so many more positions. AlphaGo does.
Right.
Um, so let's say you find out in one of the games, let's say in game one against Lisa Dole, it
Mm-hmm.
makes some mistake.
Right.
Then before the next day, how is Google going to fix that? So if it's a very specific thing, they could add it to their opening library to basically tell it, don't play this, don't
That's a
play this
no.
Joseki. Yeah, just don't do that. And they said that back in October they didn't have an opening library. Um,
Oh wow.
they just played. And so that's one of the things they could add before March, and that would help them avoid kind of repetition of some specific mistakes.
Interesting.
But if it's sort of some kind of problem, like Lisa all finds out that okay, when you have two or three different fights going on, AlphaGo just loses it. He's going to set that up in the next game and again. So that's not something they can kind of then easily fix.
Interesting. And do you think the time settings matter for a computer too much? I mean, obviously, if you gave it like a year to come up with the best position, it could probably find the best move after all that time. But I mean, I think they came out and said it's like 2 hours basic time, and I don't know how much for Byoyomi. Do you think something
It's
like that is a huge factor in deciding how strong it is?
um well, what they said in October is that the computer played very fast,
Mm,
played like 5 seconds a move or something. So
right.
it was not using its time well. And I think that was something they probably just had not worked on, kind of using the time well. So they just played fast enough to make sure they were within time limit. Um, but I think that also threw off the human player
Oh,
because
right.
if you have somebody instantly responding to your moves, it gives you less time to think. And they only had 1 hour per player
Oh,
for that game.
really?
Yeah. So having 2 hours here, I think will help. Um, and it's 3 times 1 minute Byoyomi, and I think it was 30 seconds of Byoyomi on the other one. So I think having the bigger time limit will help the human player probably more than the computer.
Yeah, there's that. What you said is true because even in a human versus human match, if you spend some time thinking about the move, your opponent gets that time as well.
Right.
So that's a useful point. So I guess we're just gonna have to see. I'd love to talk to you about this again afterwards and either commiserate over alcohol or celebrate over some alcohol. My plan is maybe I want to get maybe two or three people together just to talk about this because it's
Yeah.
just gonna be it's pretty momentous just to have something like this happen and
Right. It's like the Kasparov Deep Blue match for us. So
you know how much do you follow the Kasparov versus Deep Blue when it happened?
I followed it some, but not. I'm not a chess player, so I
Ah,
did.
I see. Yeah,
Yeah.
because I'm wondering how much like even the time aspects or how the reactions how that was as well. But so you're not a chess player, but you are a Go
Uh,
player.
yeah.
So let's segue into you. What how did you start playing Go?
So I was at ETH Zurich, and I was working on Othello program. And the professor I was working with there, he was wondering whether I knew this game called Go.
And you
And
said, "Wait, no, that's
so,
Othello."
yeah.
Like everybody who I see, you're like, "No, you can't flip
So,
him."
yeah. So I told him, no, I don't know that game. So he took me to the Go Club in Zurich. And so then I was hooked. And um, then I started doing a semester project on that, and then diploma thesis on it, and then my PhD thesis
Oh
on
wow.
that. So yeah, so basically did SmartGo as my PhD thesis. So can, this is
Oh wow. That's
that one.
so Othello was the basis for it. That's
Yeah,
you
yeah,
rarely ever
started
hear
with that.
that because I
Yeah.
usually every time someone comes to the art club and says, "Oh yeah, is this Othello?" It's like no, and then they
Uh-huh.
just that's the end of it.
Right.
But for you, it was the beginning of it. And so when you started SmartGo, was that sort of the were you doing an AI sort of idea or was it something different?
So first it was more kind of just create an electronic board so that you can use a computer as the board instead of the real board.
Oh, I see.
And so with computers back then, that turned out to be quite a challenge already to do that, to make it useful enough that you would actually want to study using the computer instead of using a board.
That is true. We forget
Uh,
even how complex counting is, or just being able to keep track of liberties or eyes, especially
yeah.
back then. That was this in the 1980s or
So that was in the 80s, yeah. So I started on this in 84, um, and started it on a Lilith computer in Model 2,
Huh.
and then went to the Mac and kind of kept doing it on the Mac. And the professor I was working with, he went to North Carolina,
Mm.
and so then took a bunch of students with him. So I went over there uh, with him in 86. And then in 89, he went back to Switzerland, and I was not done with my thesis yet. So I went back to Switzerland with him, finished up, and then went looking for a job back in the US.
Right. So I'm actually also curious what Go, and I guess we'll talk a little bit about the history of computer Go again. But like when you were in when you went to the local Go club, what was that like in the 80s? Like was it a big club? Like were people really excited? Like what was the general makeup of the club back then?
Um, in Zurich, they probably had 10 to 15 players every
Uh-huh.
night, and or kind of
Every night.
not every week.
Okay.
So they met once a week, and every week they got a bunch of players there and met in a restaurant, and well, it was good. And yeah, there was one old Japanese player there,
Mm.
and I think he was about three dan. So he was definitely the best one there. Um, and the professor I was working with was a 1Q.
Mhm.
So yeah, I worked my way up to I think about 5Q while I was in Switzerland, and then kind of improved when I came to the US.
And then so let's go from there and to the just the general idea behind computer Go. And I know uh, I've seen a lot of different things about computer Go even back then. I mean, I remember I had the small strange floppies and I never understood it. I probably thought it was Othello as well, but
Yeah.
it they had Go back then, and I think it was just really rudimentary, just like a computer playing. What was computer Go like back when you first started out? I mean, I know you were probably one of the first people to really uh,
Well,
start with it.
yeah, you didn't have a lot of computing power,
Right.
so you could do some tactical problems and figure out kind of capture some life and death and do that. Um, and you could do some pattern recognition, and you try to figure out some way to estimate kind of the influence of stones, and then when you had influence, try to figure out, okay, is this real territory or is it just kind of some moyo or
Hmm.
something, and then figure out some moves based on that.
Hmm.
But yeah, computing power was limited, and that was as much as you could do back then. And one Bruce Wilcox
Is he the
did a lot.
guy? I remember there was a guy who had a picture of himself with a chicken. Is that Bruce Wilcox for one of his?
Might be. I don't remember the chicken. But he did a series of instant Go
Hmm.
lectures, and so he learned Go as he was programming it,
Oh wow.
and so his approach to Go was also kind of influenced by, okay, what could he program, and um, he then looked at the board in ways with like sector lines. You see kind of two stones,
Hmm.
and you draw a line between them. You try to jump out if you're inside that line, and basically simple rules for kind of running fights like that.
Hmm.
Uh, Rules for contact fights. Um, Try to get 5 liberties if you're less than 5 liberties.
Hmm.
Try to get more liberties, things like that, and that worked pretty well with the technology that had at that time,
Mm.
and it made him really strong. I think he was 5 or 6 down,
Oh wow.
and played really fast, just using these things. So um, and David Fotland did a lot of um, yeah, computer Go, and he's still active. Also, I think he's using Monte Carlo techniques now, but combining some of his older code in there for evaluating positions and patterns and things like that.
Cool. Yeah.
So,
Yeah, because I know. Yeah, the software. I don't think there's much Go software other than the AI stuff. Because I know you have your SmartGo, and I know there was the Go D or Go God,
Go God, yeah.
and then I think Bruce Wilcox had his own, or was Bruce his own software, or was Bruce Wilcox Go God? I forgot.
No, Go God was John Fairbairn
Oh, that's
and
right.
T. Mark Hall, yeah.
Hmm.
Um, and John Fairbairn is still kind of doing that, collecting the games, and
Interesting.
so and that Go God collection is now in SmartGo.
Oh, okay.
So yeah, so those 85,000 games that are in there, they are now from Go God.
Oh, cool. Yeah, I mean, was it interesting back then just being, because I can't imagine there were too many people, just all of you just knowing each other and what you guys were doing with Go and with the software? Like, was that like a pretty close-knit band of people thinking about it?
Um, Somewhat, but you didn't have the internet back then,
Oh, that's
like you
right.
had. So,
I forget about that.
yeah, you saw each other at like tournaments or so. Um, but yeah, it's not like today.
Right. Yeah,
And then
go ahead.
in '91, I sort of left the community more or less and
Mm.
went to industry until 2000. So yeah, I then came kind of back into it like 97, 98. I started working on some computer Go again.
I see.
But for a while, I was just, yeah, working on PowerPoint at Microsoft and busy there.
Cool. So let's talk a little bit about just computer AI Go again. And I think we've talked a little bit about it with just how the Monte Carlo system works. The thing I'm really curious about is sort of the creative aspect of Go as well. As I talked about in my previous interview with Hajin, sort of a Go right now it's studying things and it's running simulations. It feels very much reactive to me. But I'm wondering if it can be creative in the way that it can come up with maybe a new opening or a new style that we've never seen before. What's your perspective with maybe computers and what we define as creative with styles of play?
I think at some point computer will come up with some moves that we have not considered and kind of create some new joseki or so. Whether they will come up with a completely different style
Hmm.
of play that then people see that, oh yeah, we should have been playing like this,
Right.
and
We should
that
start
it's a
with
lot.
Tengen or something.
Yeah, we should always play in some particular way. I'm not sure that that will happen. That it's not clear to me because one interesting thing is that until AlphaGo came along, you could sort of see whether it was computer playing or not. They had more of a particular style.
Right.
Um, and then AlphaGo plays much more like a human.
Right.
You can't really tell that it's different.
Hmm.
And so I think humans are already so good at Go that I think we'll rather see more of that. That they play more like humans, um, and once in a while they come up with some new Joseki or spectacular move or something like that. But I don't think they're going to be introducing a whole new different style of playing.
Interesting. Yeah, I that's a good point to make about that. 'Cause I have no idea what to add to that. But yeah, it's we'll have to see how it goes. I want to see like different styles because that's right now. I think if you hear listen to some pros talk about it, they say, you know, the style, if you can say that, for a lot of newer players is just really heavy reading, and just if this move works, it works. It really doesn't matter about shape, about style, and stuff like that.
Hmm.
And I yearn for a day where we can have like another Takamiya or someone who has this style of play that only they can do that other people are very difficult with. But I also wonder how even something like SmartGo would react to something where it's a completely unconventional style with like
I
there's
mean, AlphaGo
oh
or
sorry, yes,
yeah.
AlphaGo. There's
Smart,
always
smart,
something Go.
yeah. Yeah.
But how AlphaGo would react to that, like if someone played like the Great Wall opening or just started at Tengen and seeing uh, how it would react to certain things like that. With that horrible slip of the tongue, let's talk about SmartGo. So that was originally your thesis, and then you eventually wrote it to become this interesting piece of software where uh, you can record games with it, and you can also use it to analyze board positions. What were your you said you wrote the SmartGo software to simulate the board. What about SmartGo, your the actual software that we see today? What were the origins behind that?
Yeah, so back in like 97, 98, I was looking at kind of the progress that ComputerGo had made since I left like in 91. And they were still playing pretty poorly. I so I thought, well, it's not too late to get back into the game and do something. So I started um, uh, writing some new code for Go, and at that point I started with C++ because that was what I was using in PowerPoint
Hmm.
and kind of what I then knew best. And so I worked on some kind of AI trying to play as well as it could, but also working on kind of creating a tool for Go players. And then as time went on, I focused kind of less on the AI playing part and more on the tool part.
Was it something that
Then
you wanted to see for yourself as well? Like,
right, I want to use it myself then, and I've always kind of been attracted to kind of user interface design, and
oh,
so so then in 2007, I had the Windows version of SmartGo, and Apple then announced that you can now write apps for the iPhone. And I thought, oh, that would be good to have thousands of games in your pocket, and you could replay them
right.
at any time. So I started kind of porting some code over to the iPhone, and then I thought, okay, that I'll have the Windows version, I'll have the iPhone version, and I'll continue with both those. And then the iPhone version just took off.
It's
And
amazing because I remember even when it was just the Palm and everyone would use that to record games, I was like, I really want that, but I don't want to. Palm had its own little quirks. I mean, I think like the battery, if the battery dies out, everything disappears and stuff like that. So
right.
the whole iOS when that came out, that was my introduction to a lot of your software because it made it a lot more direct and immediate.
Yeah.
Um, yeah,
And and
go ahead.
and then Apple came out with the iPad, and it's like the iPad was exactly what Go players needed. It's like a bigger surface. You could do the 19 by 19 board and just tap to enter the moves, and yeah, made game recording really easy at that point. And
It
uh,
is your software is still probably one of the best pieces of like Go software there is out there. I mean, I
thanks.
even though I occasionally curse your name if I run into a weird user interface quirk, the one where it's like, delete to remove a move like instantly is one that took so long, and I mean, you still might not even see it on some Go programs, and it's the most ingenious thing I've ever seen. And then even then, like when I use it for review, they have like you can skip 5 moves in the book view, which is definitely not something you expected because I showed you that.
Right.
But
All right.
it helps out so much because then I don't have to tap so quickly. I can just okay, these are the next 5 moves.
Yeah.
It's a really cool thing. The reception for it must be enormous. Uh, I mean, when did you start seeing it like really take off? Was it just right from the gate, or was there
It
like a
it did really well, yeah, right in the beginning, and then went down a bit. But then when the iPad came out, it
Mhm.
really kind of took off. And uh, yeah, for 2 years it went really well, and since then it has gone kind of down again, I think. And a lot of people having apps in the App Store see kind of the same thing, that sales in the App Store have just in general gone down. Now, of course, if AlphaGo has seen a nice spike back up as regular people get interested in Go, and so I have the SmartGo Player app that where you can just play against the computer and has a tutorial to teach people
right?
Go, and so yeah, a lot of people found that one, and that's been nice.
Yeah, you've done a lot of really good things in terms of teaching. I know you have the SmartGo Kifu, which already comes with a lot of Go problems, which is great. You have SmartGo Player, and then you also have SmartGo Books.
Right. So the Go books. I basically started thinking about that when the iPad came out,
Mhm.
and then I created the book view where you um, see a game not just kind of move by move, but you see a diagram with several moves and then a comment next to it.
Mhm.
And so I figured, well, I can. Um, the book I really want in there is Invincible,
Mhm.
and so I started working on, okay, what do I need to get that book in there, and started yeah, working on the Go books
Hmm.
as a separate app and having books in there, and started out with 8 books, and now it's 109 Go
Oh,
books
wow.
in there. Yeah.
It's
So that has been taking a lot of time, kind of reviewing. And in the beginning, every time I added a new book, I had to make changes in the program to kind of accommodate features
mhm.
that were only present in that book. But now I've been able to kind of add more books without making changes to the program, at least.
That's interesting that you have to change the code just for a certain book.
Yeah.
And I know you have plans with that, bringing it to Android, correct?
Right. So there's somebody working on an Android version for that, and he has had some setbacks, and uh, yeah, we'll have to see when that's coming out. I can't predict the timing
Yeah,
on that one.
it might be harder than
So
predicting when computers defeat humans.
yeah.
But it's really great as a learning thing, and it's helped me out a lot. Definitely, uh, beyond just being able to record my games or review them, just the immediacy of just being able to look back on it. Because I remember still just writing it down with red and black, or just trying to remember 'em from my head.
Yeah.
It's so much nicer just to have that. Let's go with a little bit of trivia right now. I think some people might know this, but some people might not. With the idea behind the name SGF, and it's a different way you've definitely made your mark in the Go world. For those of us that don't know, SGF stands for SmartGo File, right?
Right. Or
And
SmartGo format,
or
or
SmartGo File.
yeah,
Oh, my
of
bad.
either one, whatever.
And
Uh,
that must be pretty amazing to just see that your original design for that has become sort of the standard for Go recording Go.
that that is pretty amazing, and yeah, there are clearly things I would have done differently if I had known that this was going to live for that long. I just needed a way to kind of save the games from my program, and so I came up with that format. And yeah, definitely the coordinate system that I used there was not the right choice. So I've regretted that many times, not using the standard coordinate system. But back then, um, using only 2 bytes instead of like 2.5 bytes
Right,
per move could make a difference.
right.
So definitely wrong choice.
But
Uh,
it's not too late to probably improve it just slightly, I'm sure.
No, the problem is that even making a small change to the format now, you can't get all the programs out there to
Oh,
adapt that.
that's right.
So SmartGo can actually read files written with standard coordinates. So you can have some of the standard coordinates in there, and SmartGo can read that.
Hmm.
But a lot of other programs cannot digest uh, digest that.
So
But
it's an
that it
interesting albatross where it's flattering, but then you're like, I could have done it better.
yeah right. So yeah, and back then there was another format, kind of the Ishi Press Go format,
Hmm.
and Martin Muller and I, we kind of wrote to Issue Press a number of suggestions on how they could improve their format,
Right.
because we thought that yeah that would probably kind of be the standard going forward, and we wanted to see some improvements, but they never made any changes
Right.
along those lines, and then at some point that pretty much died out, and SGF took over.
Much to your delight and
Chagrin, yeah.
no, but it's so cool to just see how Go has changed from that. I mean, I wonder how people like recorded games even like in their program. Did everybody use SGF when it first came out, or was it just like even among different other Go programs? Did they use SGF, or was it just a split, or did they have even their own format as well?
Um, I think a number of them use their own format, and then some people switch to this issue press
Hmm.
format. And I don't know exactly how SGF kind of
Maybe it was because of
competed.
KGS. That's how I know about it.
Possibly, yeah, they spread it.
Yeah, Internet Go has definitely changed so much about how we perceive and interact with Go. And just it's impressive to just see how it's changed everything. I mean, especially for you, in terms of not just technology, but just seeing how people interact with each other and use your software. I mean, is are there any
Right.
certain places that you've seen SmartGo being purchased or being used that you would have never expected, like a certain region, like maybe Brazil or Cuba or like
I
some.
see some sales from pretty much all over. Um, so that, but just scattered ones. But um, the big sales are definitely yeah US
Hmm.
first. Um, Japan is pretty big. About 20-25% of sales of Kifu are in Japan.
Oh,
So, and China, Korea are about 5% at this point.
I hope
So,
they get a little
oh,
bit better because I've seen some of the Chinese software for how they use it, and I'm just like, oh, gotta go back to SmartGo again.
yeah,
But
yeah.
no,
So it
that's
has room to grow there.
yeah, definitely. But it must be really nice to see just at least some sort of mark that you've made in the Go world and like that. It's like
Yeah.
to just be able to walk into the Go Congress and just see everybody on their iPads just like clicking away.
Well, but not everybody yet. It's
Yeah,
there's yeah,
there's still some sort of fragmentation, I guess,
yeah.
between Android. I think I've seen what's his name, Gurjeet, use like a Windows running a C Goban just to record
Right.
them.
Yeah.
But even then, I every time I see someone use that and they have to like change the tree because they just made a misclick, I just smile a little bit. It's like just use the iPad, use SmartGo. It's much easier.
Yep.
But yeah. So and have you actually used SmartGo to teach your son uh, Go? Has he been able to use it a lot, or
So
when you taught your son, were you still just sort of like, here's a board, we're just gonna play Go, or have you been using technology usefully to teach
well,
even
so
like your
he
son?
is using that on his iPhone now,
Uh huh.
but kind of more, yeah, on his own. Um, so yeah, I don't think that was instrumental in getting him to play.
Yeah, it's yeah. I There's so many different ways to teach Go, and definitely seeing how your software has been useful for that has been really cool. With like Go problems or just I need to try out SmartGo Player in a little bit just to see how we can use that to teach someone because teaching seems to be the most difficult thing in getting new players to show up. I mean, the existing
Yeah,
players they can find ways, but like teaching ways to make it exciting, ways that they can make it easier, that their accessibility to the game is pretty key, and just anybody who's just interested.
right. At the Go Club here in Salt Lake, we also get people coming kind of once, and we teach them, but then they don't show up again. It's hard to make it stick. But
Yeah. So like an app like that, I'm gonna have to start doing that. Just point people to the app and just say, hey, look, just download this on your phone and you can learn on your own time. Because it used to be that we'd have to just say, we used. I remember when we still had like Go pamphlets, like like going
yep.
around handing them out, just saying, oh, have you heard about the wonderful
Yeah.
game called Go? And then now it used to be pointing them to websites, but just pointing them to an app and say, hey, you can learn this out and try it. That's probably going to be really useful from here on out, especially
Mhm.
with the AlphaGo. Let's see, what else can we talk about? I think we're we've hit most of the
Yeah.
topics that I want to talk about. I think what things do you want to see moving on? Uh, be it with computers and Go, or uh, maybe personally, how you want to see the code community move on. Is there anything in particular, like maybe with something, even with something like AlphaGo, just with it getting stronger? Is it just that you want to see it getting stronger than being able to use as an analytical tool, or just being able to have it sort of almost be recognized as a professional Go player? Like,
Yeah, I hope that Google sort of makes it available for people to play against and analyze games and things like that. So I hope they don't like Deep Blue, IBM did it and won against Kasparov, and then they basically uh, didn't continue with chess at that point. They
mm,
kind of then used that technology in other ways, but didn't continue with chess. And I hope that Google, once they beat the top human player,
let's hope that's.
hopefully not now, but we'll see. But once they beat a human player, I hope they don't kind of completely withdraw from Go,
Right.
but that they keep using Go sort of as a research tool, and then make that available also for other people to play against and professionals to train. And
Now, do you think that's something that's maybe eventually, but is it something that we could all have like a version of AlphaGo in our pocket, or is it still something that, as we're seeing it as it is, it's going to require a ton of servers, a ton of processing power behind it for us to easily use for our own purposes?
well, right now it uses a lot of processing power,
Mm-hmm.
but for one thing, I think once they figure out better kind of how to do it, they can reduce the need for the processing power.
Mm-hmm.
And also, if you look at something like the Zen program,
Mm-hmm.
it was running on just a desktop with um, 12 processors, maybe, or something like that.
Huh.
So, which is something that like we're going to have in our pocket within the next 10 years.
This is insane.
So, so, so yeah, I think the moment will come when you can have AlphaGo on your phone pretty much, and
Get frustrated with
uh,
the computer.
yeah,
Yeah, some people have asked me if it's a big deal to me, and if I'm just like, it's stronger than me, and I still need to get better at Go, so it doesn't change anything in my life too much.
right, right. It's already stronger than me too. So yeah, it's
And so that's. Do you think? I mean, I think so. The first big huge change was the was using Monte
Monte
Carlo,
Carlo. Yeah.
and then now it's the neural network. Do you think there's still maybe something out there that we are you hoping for something out there that's maybe a new approach to Go, like in terms of AI that we haven't seen yet, or is this pretty
I
optimized?
No, I think there's more to come. Like if you look at the Monte Carlo um, programs, one problem that they still had before AlphaGo, and we don't know whether AlphaGo really has
Hmm.
this problem or not.
Ooh,
But
this is good. This is gonna be good.
one problem they had was when there were multiple unresolved positions on the board.
Mm-hmm.
There's some hard semi in one corner. There's a life and death problem that's hard to read and might be a co in another corner. And there's a fight going on in the middle game. When there's a lot of things going on like that, then the Monte Carlo search kind of
Breaks
can't.
apart.
Yeah, because it's looking at the whole board. And so in those situations, you would want to sort of solve each one separately
And then
and figure out what's
prioritize.
going on, and then yeah, figure out how to combine them and best play globally. But you might need more computing power just to figure out the result locally. And if you're distracted by all the things going on globally, you might not be able to get to the bottom of what's going on in that corner.
Right.
And so that was a weakness of the Monte Carlo programs, and I think there's probably some way to work around that and figure out a way to address that issue.
That's an
And
interesting question. Would you accept a win of the humans over AI if they were able to exploit something like that?
yeah, yeah,
You would. You would. It feels very
yeah.
much like, oh, you're just trying to find the loophole within the system. But and like for me, it'd be a little bit harder. It's like, well, if you can't beat them in a like a a good fight, and you have to like fight dirty, I'd be a little bit more like, well, I guess that's the difference between humans and AI, but it still feels like. But you would be able to say, okay, well, that's where we need work on, and if that's how humans are going to win, I'll accept that win.
Right, and people just have to keep working on AlphaGo and other programs to figure out how to get past that. Um, so yeah, it's possible that Lisa Doll may be able to find some weakness like that.
Right.
But in the AlphaGo paper, they also describe something they've done to kind of keep track of some local results as they are looking ahead.
Huh.
And so it's possible that that is helping address that problem.
Right.
Not quite clear. So it will also be interesting to see. I think once the Lisa Doll match is over, I think the researchers will be more free to talk more about what they're doing,
Right.
what's working, what's not working, what they plan to do.
Regardless
And
of the result, I'm
yeah,
guessing.
right, I think so. And so it will be interesting to hear kind of what they have done since October, what
What they will
they
do.
plan to do. Yeah,
That's and I guess that's a good way to end things. I mean, we're just gonna have to wait and see.
yeah,
But I want to
not too
thank.
long now.
Oh gosh, I'm rushing to get at least one or two interviews done where we talk about this before it comes out, because then if I make an interview before like in between, and we talk about it, and then the answer's already known, I'll look at the interview like, what was I thinking saying that? I regret saying these things.
Yeah.
But I really want to thank you for showing up first of all, and like being able to do this with me and just talk about what you've done. And I definitely thank you for making SmartGo and SmartGo Kifu and all these other things. It's been
Oh,
really
thanks.
cool
Well,
to hear about how it's been made and how it's been, and at least tell you how much it's helped me, even though I still have my quirks with it.
yeah. Yeah, thanks. No, this was fun.
And it's also really cool for you to explain some of this to me. I've seen a lot of different people explain it. Um, I fall asleep for most of them, and I'm still awake now, so that's
Yep.
good.
Good.
But it's also useful to see how it's changed. Because I mean, it's nice to know that where we are right now with like how close we are to it being so viable as like a really strong uh, to match professionals. But it's also really interesting to know where we've come from. Where it when you started out, it was just being able to make a board, and then now it's being able to, and then being able to play, and then just seeing how it's evolved. So, thank you for
Yeah,
definitely showing up and explaining that.
sure. Yeah.
And we will definitely have to talk again after in a couple of weeks after this happens,
Right.
and we will have to maybe when they talk about it, and then you can help me make sense of it a little bit more.
Okay.
So thank you again, Anders. And I will have to see you and the audience members soon. So thanks, guys.
Yeah. Okay. Yeah. See you.